AOP with Spring Framework. What is aspect oriented programming? AOP is a programming paradigm that allows separation of cross cutting concerns like logging, security, and transaction management from the main business logic, improving code modularity and maintainability. Basically, it is a key component of the Spring framework that allows developers to modularize and manage cross cutting concerns in application. Key concepts in Spring AOP. First one is aspect, a modularization of a concern that cuts across multiple objects. They are a class annotated with aspect. Second, join point, a point during the execution of a program, such as a method execution or exception handling. In Spring AOP, a join point is always a method execution. Third, advice, action taken by an aspect at a particular join point. Types of advice include before, after returning, after throwing an around. Fourth one is point cut, a predicate that matches join points defining where advice should be applied. Fifth one is weaving, the process of applying aspects to the target object to create a new proxied object. Real time example, that is airport security process. Think of an airport security checkpoint where before security check, security staff logs details about the passengers and checks their documents before allowing them to process. After security check, after the check, they record whether the passenger cleared security and may store additional information about the process. Mapping the code to the example. Aspect. It represents the airport security process which observes and logs events during the passenger screening process. Before. Log before method. Logs passenger details before the security check begins. Example checking passports, boarding passes, and etc. After returning, that is log after method, logs the result of security check after it is completed. Example security cleared or needs further inspection. Target methods, the execution, that is com.example.service, means the AOP aspect is applied to all methods within the com.example.service package representing various passenger related services. How it works. Passenger begins security check. When a method in com.example.service is called, the log before method is triggered, logging the method being executed, like checking a passenger's boarding pass. Passenger completes security check. Once the method completes, the log after method is triggered, logging the result like security cleared or additional screening required. Practical applications. Logging in banking systems. Logging details of a transaction before it starts. Example processing transaction for account X. Logging the result after the transaction. Example transaction successful with ID 1234. Monitoring APIs. Logging API requests and responses in web services for debugging and performance monitoring. Auditing user actions. Logging user actions in a system, example, login attempts or change in sensitive data. Real time analogy applied. Passenger arrives for security. So, before logs, the passenger's names and boarding pass details. Security check is completed. That is, after returning logs the result, example security cleared or needs additional check. This demonstrates how AOP helps add cross cutting concerns like logging, monitoring, or security without modifying the core business logic. Benefits of AOP. First one is separation of concerns. Keeps business logic clean and focused by separating cross cutting concerns. Second, code reuse. Common functionalities like logging can be reused across multiple modules. Third one is flexibility. Easily apply or modify cross cutting concerns without changing the core business logic. JDBC Framework Overview. What is Spring JDBC? It is a Spring module within the Spring framework that used to work with the databases. Spring JDBC is a module of Spring framework that simplifies the use of JDBC to interact with relational databases. It provides a consistent approach to manage database resources and executing SQL queries while reducing boilerplate code. Let's discuss about some core components of JDBC. JDBC template. It is a central class for performing JDBC operations and manages connection and simplifies query execution. A central class that simplifies databases access, provides methods for querying and updating data, and handles resource management. Second one is data resources, an abstraction for a connection to the database typically provided by connection pool. Abstraction for database connection pooling. Row mapper maps rows of a result set to Java objects often used to convert query results into domain objects. Simply, it is an interface used to map rows of a result set to Java objects. Fourth one is named parameter JDBC template. Extend JDBC template to allow the use of named parameters in SQL queries. Benefits of Spring JDBC. First, it simplifies error handling and resource management. Second, reduces boilerplate code, making database operations more concise. Third, it integrates seamlessly with other Spring modules such as Spring Transaction Management. Real time example, that is retail store database query. Imagine a retail store management system where database, that is customer table, is stores customer details like name, email and purchase history. Services, that is find all customers. A service fetches all customer details from the database to display on an admin dashboard. Mapping the code to the example. JDBC template. It represents the tool used by the service to interact with the database. It simplifies SQL queries, eliminating boilerplate code. SQL query, that is select star from customer. It represents the query executed to fetch all customers from the database. Bin property row mapper. It maps each row in the customers table to a customer object automatically by matching column names with the class fields. Find all customers method. The method queries the database and returns a list of customer objects representing all customers in the database. How it works. Service execution. The find AII customer method is called to fetch all customer data. Database interaction. The JDBC template.query executes the SQL query, that is select star from customers. Each row in the customer table is mapped to a customer object using bean property row mapper. Result returned. The method returns a list of customer objects, each representing a record in the customer table. Real time analogy applied. Retail store database. You have a database containing all customer details. Talking about admin panel. When the admin wants to view all customers, the system executes the find all customer method. The result is the admin sees a list of customers displayed on their dashboard. Real life use cases. First, e-commerce platforms. It fetches all registered customers to analyze purchasing patterns. Next is CRM systems. It retrieves customer data to send personalized emails. Next one is admin portals. It displays customer details on a dashboard for review or updates. This code showcases how Spring simplifies database queries and object mapping, making the system easy to maintain and scalable. Transaction management. What is transaction management? Simply, transaction management is the process of managing a sequence of operations to ensure they are executed in a reliable, consistent, and secure manner. Transaction management in Spring ensures that a series of operations are executed in a way that they either all succeed or all fail, maintaining data integrity. It handles transaction boundaries, ensuring that all operations within a transaction are completed successfully or rolled back if any operation fails. Here we discuss some of the key concepts of transaction management. Transaction, a unit of work that is either fully completed or fully rolled back. Second, transactional, an annotation used to define the scope of a transaction. It can be applied at the method or class level. Third, propagation defines how transactions should interact when a transactional method is called by another transactional method. That is, requires new. Fourth one is isolation. Defines the level of isolation for the transaction, controlling how the transaction is handled with respect to other transactions. Example, read underscore committed. Real time example, that is bank funds transfer. Imagine a bank system where customer A, that is from account, wants to transfer money to customer B, that is to account. The transfer process involves debiting money from customer A's account and crediting the money to customer B's account. Both operations must succeed or fail together, otherwise, there will be inconsistency in the accounts. Mapping the code to the example. First one is service, that is account service. It represents the service that handles business logic for transferring funds. Account repository, used to fetch account details from the database and save the updated balances. Third one is transactional. Ensures that if any part of the transfer process fails, example debit or credit, the entire operation is rolled back, leaving the database in a consistent state. Transfer funds method. Execute the transfer operation. Step 1. Retrieve the accounts, that is from account and to account from the database. Step 2 is debit the amount from the from account. Step 3 is credit the amount to account. Step 4. Save the updated accounts back to the database. How it works. First is initiating the transfer. The method transfer funds from account ID to account ID amount is called to transfer funds between two accounts. Transactional behavior. If any step fails, that is, insufficient funds in from account, database connection issues, then the transactional annotations ensures that all the changes are rolled back to maintain consistency. Real life example flow. Customer A wants to send $100 to customer B. So first step, transfer funds, that is 101 and 102 and 100 is called. Customer A's account, that is from account, is equals to 101, balance is equals to $500. Customer B's account, that is to account ID, is equals to 102, balance is equals to $300. So the process will be retrieve account from the database, debit $100 from customer A, that is $500 will become $400. Third step, credit $100 to customer B. Fourth one is save the updated balances. If an error occurs, suppose the credit to customer B fails. Example, network issues. The transactional annotation rolls back the debit from customer A, ensuring both balances remain unchanged. Practical use cases. Banking system. Money transfers ensures no loss or duplication of funds. E-commerce payments, deducting payment from a user's wallet only if the order is placed successfully. Inventory management, reducing stock only if the order is successfully confirmed. This ensures atomicity and consistency, demonstrating the importance of transaction management in critical systems. Benefits of Spring Transaction Management. It simplifies complex transaction management. Transaction management ensures consistency and data integrity. It also supports declarative transaction management using annotations. Spring MVC framework. What is Spring MVC? It is a design pattern used in Spring framework to build web applications, and it is a powerful and flexible framework to build web applications. It separates application logic into three interconnected components: model, view, and controller. Core components of Spring MVC. Dispatcher Servlet acts as the front controller, handling all incoming HTTP requests and directing them to the appropriate controller. Controller. It is the processor user request interacts with the model and returns a view. Model. It represents the application's data and business logic. View. The user interface that displays the data to the user, typically using JSP, ThinLeaf, and another templating engine. View Resolver resolves view names returned by controllers to the actual view implementations. Request flow in Spring MVC. It represents how a user's request is processed and responded to. Client request. A user sends HTTP request to the web application to access a resource or perform an action. Dispatcher servlet. It acts as a front controller. It intercepts the incoming request and routes it to the appropriate handler. Controller handles the request, interacts with the model, and returns a view name. The front controller consults the handler mapping to determine which controller should handle the request, and it resolves based on URL pattern and matches it to the specific method in the controller. View resolver maps the view name to the actual view. View. The view is rendered and sent back to the client as the response. Example by embedding into an HTML template. This is the model view controller structure. Here the client request sent to the dispatcher servlet, that is front controller. Then this request sends to handler mapping or controller to find appropriate controller. And controller processes the request and returns a view name or data. And then view resolver resolves the view name to an actual view file, and finally it sends the response to the client. Real-time example. Let's talk about welcome page of a website. Imagine you are building a website for a bookstore. When a user visits the web page, example home, you want to display a welcome message like welcome to Spring MVC. So mapping the code to the example. First is controller. It represents the controller in the MVC pattern, responsible for handling web requests and returning views. Second, getting mapping. Maps HTTP GET request to the home URL, meaning this method is executed whenever a user navigates to home. Model used to pass data like the welcome message from the controller to the view. Example, an HTML page. Return home returns the name of the view. Example, a template file named home.html or home.jsp to be rendered. How it works together. User request. A user visits http example.com/home in the web browser. Controller execution. The home method is triggered because of the get mapping. The method adds a message welcome to Spring MVC to the model. View rendering. The view named home, example home.html, is rendered with the message passed from the model. Result is the user sees a web page displaying Welcome to Spring MVC. Real life flow in a bookstore website. The scenario is a visitor navigates to the home page of your bookstore website. Behavior: the server executes the home method, prepares the welcome message, and renders for the home page with the message. Logging with Log4j. What is Log4j? Log4j is a popular and powerful logging framework for Java applications developed by Apache Software Foundation. It provides a flexible way to log messages with different levels of severity, example info, debug, error, and can be configured to log to various outputs such as files, consoles, or remote servers. Log4j is highly configurable and supports various logging levels, appenders, and layouts to meet different logging requirements. Integrating Log4j with Spring. First, Spring integrates seamlessly with Log4j, allowing developers to use Log4j for logging throughout their Spring applications. Second, Log4j can be configured using an external configuration file or programmatically in the code. Key components of Log4j. Logger, the core components that log messages. Loggers are typically created on a per class basis. Appender specifies where the log messages will be sent. Example, file or console. Layout, it defines the format of log messages. Label determines the severity of log messages, that is, debug, info, warn, error. Real time example. Let's talk about order processing system in e-commerce. Imagine an e-commerce order processing service that handles users' orders. Logging is crucial here to track the following. First one is task status, when the order processing starts and completes. Second, error tracking. If something goes wrong during the order processing, logs help identify the issue. Third one is audit trails, keeping a record of the processed orders for auditing purposes. Mapping the code to the example. First one is service, that is example service. It represents the service responsible for order processing. Logger logs important events like when an order is received, processed, or if any error occur. Log4j configuration. It defines how and where the logs are stored. File appender. Logs are saved to a file, that is app.log, for a long-term storage. Console appender. Logs are displayed in the console during development or testing. Logging labels. Info, that is log key events, example task started or task completed. Error, if added, that is logs issues or failures during processing. How it works. Order processing starts. The perform task method is called when the service begins processing an order. Logs are generated. A log entry is written to the console and a log file to indicate the start of the process. After processing the order, or another log is added. Log storage. Logs are stored in app.log, that is defined in the configuration and displayed in the console for real time monitoring. Real life flow. The scenario will be a user places an order on the e commerce platform. Behavior goes the platform task method is triggered, processing the order. Talking about logs, info, that is task started when the order begins processing. Task completed when the order is successfully processed. Practical use cases. E-commerce order processing. Logs when orders are processed successfully or if there are errors. Example, payment failures. Web application monitoring. Logs when critical tasks are initiated or completed to help developers during debugging. Microservices communication logs requests and responses between services for debugging distributed systems. Audit trails stores logs for tracking user activities or system events. So, here are the benefits of logging. Debugging it helps identify where errors occur. Second one is monitoring tracks the system's real time behavior. Third one is auditing maintains a record of completed tasks for compliance. This code showcases the importance of logging and how Log4j simplifies tracking system events. Thank you for watching the video.